agree with the Blunt-Altman analysis. Yes?
What do you think in the top left there, you've got the intercept is 14, so, you know, if we look at on average, they've got a higher critical power. Sorry. Yeah,
I've got the data here.
Yeah, okay. Yeah.
The mean difference, I've got the data here.
Yes.
Yeah.
Just can you comment on that?
Yeah, I come back to this in a moment because it raises the whole issues about the modeling and the data analysis. Yes.
Yeah, so I have a question then on the mean. So why you look at the mean difference and not the absolute mean?
We do both. We do both. When I publish papers, I basically provide pretty much every data, so people can look at it from any different angles that they wish to look at, which I think is important here. So we've basically, these are the mean values here. These are the errors in wattage. These are the confidence limits within this, and the average prediction error, which are acceptable at this from a research point of view. Yes.
Are you going to show the W prime data?
Yes, coming up. So, and here's the Blunt-Altman with the mean difference and the limits of agreements. Here comes W prime, and again, we found the data points being very much all over the place, and we are questioning at this point, and we want to go down this in a bit more detail. Maybe you already know why. Why is there such difference? So when we look into the individual data analysis, if you look into the prediction error here, and the standard error, these are massive, massive differences. Now, given that W prime is really excitable, if you could measure it accurately, for pacing strategies, sprinting, and so on, this protocol that is there cannot be used because this value is not, these values are not good enough. Now the question is why? Do you want to kick in for a second here? What your spin is on this, Christoph?
Yeah, the why. We do not know exactly right now what are the real reasons for the differences, but we did some pilot testings. We compared critical speed, so we did some running research, and it might depend on the duration of the prediction trials. So you did the time to exhaustion trials,
yes.
So I think it was not possible to match the exact durations for each trial for each participant. So in the first test, the time to exhaustion trial was, let's say, 320 watts, and on the first visit, the participant rode for 12 minutes and 11 seconds, and during the second visit, same power, constant power, but the time to exhaustion was 11:50, let's say. So we have a difference in the duration of the prediction trials, and that might lead to differences in W prime. So we did some testings where we equaled prediction trials. So we did time to exhaustion trials in laboratory, and then did time trials, running time trials under field conditions on athletic tracks. So for instance, time to exhaustion was 12 minutes 15, and then our participant had to perform a time trial with the duration of 12 minutes and 15 seconds on the track, and then we measured the distance, and yeah, results are telling us that we found some solution for non-significant differences in W prime.
And you can see this also, you can see this in the data was given also if you look into the durations here, there are differences in between. This is protocol A with 24 hours recovery, 3 hours recovery, and 30 minutes recovery. It is, you can't compare them, and it might be one of the causes where, when we started to define the research, it was all about how long does W prime take to fully replenish. Does it take 3 hours? Okay, that was the duration of the lecture. Or does it take shorter? So we worked with the current literature, and I introduced you to another research because we were not sure whether 30 minutes is actually too short for full reconstitution of W prime.
Just point out, I've got pilot data, like I did a project last year using your protocol, and in our subject population, the 3 minute, the last test, the 3 minute especially, the guys, like I know the guys very well, and they're subjects in lots of projects, and we train together, and we have lots of 3 minute data on those guys, so it's not a study, but very, very, almost never were they able to get their best 3 minute power that they can do when they're fresh when we did your protocol.
Yes.
So I do think that there's
W prime is compromised.
That's right. They can't recover fully
Yes,
in
W
30
prime.
minutes. So that will tend to decrease W prime
I
and
agree.
maybe increase
With
critical power.
No, I agree with this, because that was the latest work. I'm writing a manuscript at the moment based on the 30 minutes. This is not potentially not long enough for the full reconstitution. What we did here was, because okay.